So we are the Doctors AI team, and our project FIP project is about diagnosis assistant based on multi LLM collaboration. Our team members are Juzail and Isra. So our research is based on a real background context. So in real world settings, whenever a new patient comes, the doctors from different universities, different experience, and different uh, previous backgrounds, they come together and collectively collaborate between each other by discussing about each point, and they come for a final conclusion. Similarly, the doctors follow a methodological differential diagnosis. So basically, once all the patient symptoms and all the lab reports are done, the doctors, what they will do is they will brainstorm all the possible diseases, and then uh, based on the possibilities and based on the discussions, they will prioritize and ignore the less frequent one, and finally they will decide the most likely disease. So our methodology follows both the collaborative nature and also the differential diagnosis nature. So in our system, instead of single LLM doing one diagnosis part, we have multiple different LLM work together in a collaborative manner, discussing in multiple rounds to come to a final diagnosis before a clinical case. So a typical clinical case would look like this. It will have the patient's information, it will have the examination results, and also it will have the physical examination, it will have the laboratory examinations, and all the other informations. So why do we need to implement this? So currently the healthcare systems are under resourced, and by having a diagnosis assistance systems that can solve that problem, and also challenges for even for experienced doctors, and to improve the accuracy and efficiency of the diagnosis, because misdiagnosis is a critical problem in medical domain. So, what's the scope of this project? Is it intended to diagnose all the diseases? No, it's intent. So, in our FIP, we have only selected 12 medical departments, and we have done the evaluation. So, this research is only limited to those of them, and the clinical cases where all the structural information is available. And what's the expectation of clinical adaptation? Is it meant to replace the doctors? No, it's not meant to replace doctors, but to assist clinicians to make the decision confidently and help them with their day to day work. So, what's the novelty of our project? Novelty of our project is instead of it's the multi-agent system, but based on multiple different LLMs that are working in collaboration to one another in multi-rounds discussion to identify the most possible diagnosis for a clinical cases. So, do we do any training? No, we don't do any training. We only leverage the intrinsic knowledge that's already available in the LLM. Our main target is to make use of the intrinsic knowledge as much as possible. So, what is the overall architecture of our system? So, initially, we have the input, which is the clinical case and possible sets of diseases. And based on when we give them to, so we have two kinds of framework. One is the single LLM framework, the second one is the multiple LLM framework, and finally the output. For the input, we are giving the clinical case and possible set of differential possible diseases list. And in the single LLM framework, each individual LLM works separately, and they will give their final diagnosis and the reasoning for them. So overall, if all the diagnoses are same, then the directly output is given, which is the final diagnosis and the reasoning. If the LLMs are not giving the same answers, they will go to the multi LLM framework, and from there would be multiple rounds of discussion between the LLMs, and then the output would be decided. So the task of each LLM is to analyze the clinical input, select the most likely diagnosis, and justify the final choice with reasoning. So this was also as another view how the systems would happen for the individual LLM and multiple LLM framework. So as I mentioned, we don't involve any fine tuning, or training of the data. Our system is entirely based on efficient prompting techniques and how they happen. So we have four prompting techniques, which is the direct zero shot prompt that was originally used in original paper, and our own created prompt called with reason prompt, where we ask the model not only to provide the final answer but also to provide the reasoning. And finally, the check others input. So that's the prompt used by the multi LLM framework. So where with the medical case, we also provide the diagnosis by other LLM and ask them to come for a final conclusion. But here, the with reasons prompt, it's used to only to do the final predicted. It's used for the single LLM framework. And if I had with them, we are comparing our performance with. So now is the time to present the performances of individual LLM framework and multi LLM framework. In individual LLM framework, you can see the performance of individual LLM. But we are comparing when we comparing with multiple LLM framework, you can see individual LLM framework did a good job compared to the multi LLM framework. But we expect the multi LLM to work better compared to the individual, but we didn't get the results. You can see individually GPT-4o had with reasons prompt, which is one of our prompt that has outsmarted all the other different prompting techniques. But is this the end of our research? No. At the same time, we have also identified in the increasing the accuracy can be done by using the number of output tokens that is taken. So when you increase the number of output token, you can see both individual LLM framework and multi LLM framework performance has really increased, which is one of the good findings that we have. And also to increase the accuracy, we have to if we increase the number of rounds also, it converges more for a better answer. So apart from the one last part, so even though our system, the multi LLM framework, didn't outperform individual LLM framework, but error analysis showed us another pathway how our system can be used. You can see here the error of the individual LLM framework and also error of the multi LLM framework. So basically, here in the error of the multi LLM framework, incorrect cases where all the LLM incorrectly all the LLMs has incorrectly identified the same possible incorrect answer. So you can see compared to the left side, the right side have very low value. So this is where we are introducing the confidence step. So we have identified we can divide the because we can have to we can divide the answers provided by the multi LLM framework into three answers: high, medium, low. In high, where all the LLM have agreed on one answer in the very first round itself. Medium, LLM agreed on final answer within a set of number of rounds, say for three. And low, LLM did not agree on the same answer even after something like all did not agree, but they have converged for some answers even after a set of rounds. So by giving this confidence, now we can say compared to the individual LLM, our system is more safer to use and it can give a good confidence score so that uh, the doctors who use the system can confidently use the system. Now we will see an account. We will see a demo of our real application. So here you can see you can add new clinical cases. You can search the clinical case by ID and patient name. So we will mainly focus on adding our new case. So when you press the add new case, you have the option to upload the case PDF origin something like if you already have the case, you can directly upload it as a PDF. But for this demo, I will add it manually one by one. So I will. This is one of the example clinical case. I will add it here. You can see the amount of content is large, so our system solves a critical problem. So now we will add the possible sets of diseases which are. So now I have added all the diseases. The real output is the real disease is the acute pyelonephritis, which is the first disease. Now we will try to find the finding diagnosis. We will go to the backend and we'll try to find the C's. So you can see in the backend it's running properly. Initially, we have each round of discussion, and after that, the conflict resolution is happening between the three doctors. So here we have used GPT-4, Gemini, and GPT-4 Mini as our different LLMs. So everyone has, after the first round itself, they have reached acute pneumonitis as the final disease. So now you can see they have written the disease and also the reasoning part, and also you can see view the whole clinical case as much as again and again for your later references. So this is our research. Thank you.